Reciprocals. If your target is beneath the dividing line, then a useful tactic is to build the relevant side of the equation upside down and then employ the mathematical reciprocal which turns a fraction upside down. Let's look at an example. Rearrange PV over T equals NR for T. As the target T is beneath the dividing line, you should try to build T divided by PV and then take the reciprocal. Start with your target T in a box, then divide by PV to give T divided by PV. Now take the reciprocal to give the required expression of PV divided by T. From the question, this is equal to NR. Then take the reciprocal of NR. Notice that NR is the same as the fraction NR divided by 1, which makes the reciprocal easier to perform. This gives 1 over NR. Now you multiply by PV to give PV divided by NR is equal to T. Let's do a more complicated example. Let's solve 5 divided by 3 minus x equals 4. Here the target, x, is beneath the dividing line, and so you need to build the relevant piece of mathematics upside down and then take the reciprocal. Let's start with x in a box. Then multiply by minus 1 to give minus x. Next add 3 to give 3 minus x. Next divide by 5 to give 3 minus x divided by 5. And finally take the reciprocal to give the required piece of maths of 5 divided by 3 minus x. This example illustrates the usefulness of multiplying by minus 1 to change x to minus x in the first step. You can think of the minus sign as being created by multiplying by minus 1. It is also useful to remember that minus x plus 3 equals 3 minus x for the second step. Returning to the flowchart, 5 divided by 3 minus x is equal to 4. First you take the reciprocal, which is equal to a quarter. Next multiply by 5. A quarter multiplied by 5 is 5 over 4. Next subtract 3. 5 over 4 subtract 3 equals minus 7 over 4. Finally multiply by minus 1 to discover that x is equal to 7 over 4. Limitations. Although the method works perfectly well for a whole range of rearrangements, there are some limitations which you should keep in mind. 1. The method does not work when the target appears more than once in an equation, either on one side or on both sides. Take 4t multiplied by 2 minus 1 over t equals 12, and 3 divided by x minus 4 equals 4 divided by 2 minus 7x. You must use your algebraic skills to manipulate the equations until only one instance of the target is left. If this is not possible, then you will not be able to rearrange or solve the equation. Example. Solve 4t multiplied by 2 minus 1 over t equals 12. If you expand the brackets, see study guide, opening brackets, you find that the left hand side becomes 4t multiplied by 2 minus 1 over t equals 8t minus 4. And so 8t minus 4 equals 12, which is now suitable for the method. You may use it to find that t equals 2. Limitation 2. If the target appears more than once and as a different function, the procedure will not work. For example, x squared plus 3x plus 2 equals 0 and 2x plus sin x equals 3. In the first case, x is both squared and multiplied by 3, and so you have no concrete starting point for the flowchart. Indeed, this equation can be solved by factorisation. See study guide, Solving Quadratic Equations by Factorisation. However, if you complete the square first, see study guide, Completing the Square, you find that x squared plus 3x plus 2 equals x plus 3 over 2 all squared minus a quarter. After setting this result to 0, you can then use the flowchart method to solve for x. In the second case, x is both multiplied by 2 and is the argument of sine, so again you have no fixed starting point. Solution of equations of this type is beyond the scope of these study guides. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.